Okay, let's discuss today what we have done on 12th. Yeah, from today morning, I just woke up at some 7:30. After that, I did 15 to 20 minutes of yoga and skipping. Then later, I had my breakfast. After doing the breakfast, I watched the uh, comedy movie to develop the sense of humor and to leave the seriousness in me. That's why I watched 30 minutes, 30 to 40 minutes. Then later, I just uh, I just took the Python PDF from Flash series. Then I studied it for one hour. Also later on, then. mm, So first, initially, let's discuss what we have discussed in that 1 hour of Python. So the original PDF is here. Let's go it from the starting. So this is 30-day flash series. So here is what it contains. So you can have a glimpse of it. So this is all for basic and beginners. Where Python is used. So here day two. So from here on, I have used ChatGPT to know why this variable existed, why live local variables came, why. I just kept on adding why, and I just started this. A variable is a named variable location that stores. It acts as a reference or a pointer to an object. What is variable? It acts as a reference or a pointer to an object. Object is nothing but this Ravi. Ravi is a value. So in everything, it's a value. It's nothing but an object in a memory. Variable is a container that holds data. See here as given, as you can go through it. And now let's go through the Chat GPT version. So why? Yeah, exactly. Now just scroll down up. I think not even from here. Yeah, exactly. Yeah, I think these all are useless. So let's skip this. So yeah, this is the thing we need to go through initially. Yeah. So first of all, let us know why variables were introduced. Why variables came into picture. Early programs work directly with raw memory address. So, so suppose you need to store that memory address. We need to remember this in hexadecimal. Then add 5 to this memory address. Then print the value of from. Okay. So what the problem came is it is hard to remember addresses, easy to make mistakes. So code becomes unreadable. Even a normal programmer, anyone who knows programming or has an idea of this can know. No meaning they're just numbers. So these why variables were introduced. So to solve these problems, variables were invented. Instead of remembering memory address, we use meaning. So instead of remembering memory address, we used to understand to the human, and we use the meaningful names. Age is equal to 10, and age is equal to age, print age. Now age refers to some memory location. See, the system handles the address internally. So the age value now holds the address. So it's in that memory location. It's there. So real life emoji. Without memories, you can variables you remember rack numbers. So rack 4 to 1, 4 5 to 1. Some you will rack But with variables, what you'll do, you'll just label the data. So rise is equal to 20. It's much easier. Variables came into picture to hide memory complexity and make programs readable, maintainable, and human friendly. This is why variables came into picture. Now, let's go back to the local variables. See, you can here are the types of variables. Local variables are defined inside functions. Global variables are defined at level. Global variables are defined at module level, not global level. Instance variables are object specific. Class variables are shared by all objects. So variables defined inside a function are local variables and can be accessed only within that function. So you can print, you can use this x value anywhere inside the function. Outside the function, outside after this calculate, if you write any other function, then we can't do that. Now, let's look at the chat GPT one. Let's move on very slowly. Okay. So variables came into picture, local variables came into picture to control memory, avoid conflicts, and make programs predictable. Think in real life terms. You are cooking in your kitchen. You keep salt, oil, knife in your table. In your table. Your neighbor is also cooking in their kitchen. You don't want your neighbor to use your using your neighbor. You don't want your neighbor using your salt. Your knife changing because they used it. So in kitchen is equal to function. Items inside is equal to local variables. They exist only inside the kitchen. So this is whatever the oil, salt, and knife in your table, only like you should use in your kitchen. Your neighbor should not come and use that. So let's now discuss the problem without local variables. If if every variable was global, then which x should the program trust? If 100 functions modify, debugging becomes a nightmare. Names plus conflicts is equal to unexpectedness. Okay. Mm, So this is how to this we solve the program x is equal to 10. We write inside the function. X exists only when x exists only when calculator runs. Once function ends, x is destroyed. So this x gets destroyed. Local variables created when a function is called. Destroyed when function is set. In local variables is created when function is called. When function it destroys when function is ends. So it's created when the function is called. Local variable when the function ends, it's destroyed. Memory is free automatically. No waste, no clutter. Most important. They should not depend on any outside mess. So, so we'll write a function def add function name a comma b, and these two are parameters. Result is equal to result is local. No one else can mess with it. Function becomes and reusable, reliable and reusable. Why not always use global variables? Hard to debug. Local means it's easy to reason, easy to find. Shared by everyone. It's private to the one function or the functions. Private to the function. Risky. Global is it's safe. It's very bad practice. Whereas local is very best practice. Local variables exist to keep data limited to the function scope, preventing conflicts, improving memory management, and making functions predictable and reusable. A function is a mini world. Local variables are the rules inside that world. So now let's move back to the second topic. Global variables. Global variables defined at a module level and accessible anywhere in the program. It can be accessible anywhere in the program. Local variables. Okay, now let's check. Okay, this is not required. Context which is a variable scope. Okay. So with before moving down to the next topic, global variable, let's move to the like in depth into the uh, like the first variable, that is local variable. So if only if global variables exist, then which see x is equal to 10, it's settled inside the function. If both are global, function call silently changes x. No visual clue outside the function. Question 2. What if 100 functions modify x? So if keep on the other functions call and changes it. One small change breaks everything. So side effects. So it becomes debugging becomes a problem. So core problems without local variables. So what are the problems? See, name conflicts, CM variable used everywhere. Hidden side effects, function change external state. Tight coupling functions depends on global state. No, you can't reuse the code. No reusability. Can't reuse safely. No parallelism. Threads overwrite each other. Okay. Just stays inside the functions. Rule included. What happens among them? They will isolate debug. So you need to fix this mental model. So global variable is a public road. Anyone can touch, accidents happen. Whereas local variable, it's like a private room. Only your owner can use. Local variable exists to protect your program from itself. So here is the real-time example of a bank account system. So without local variables, see, now we have used global variable called, yeah, and we have written three functions and we have called the three functions. So here the any functions can change the balance. Everywhere it's global. Order matters. One wrong function is equal to money loss. So if this function goes wrong or anything is written, so it becomes loss. So so with local variables. So now we will write the local variables. Now we'll add it and we'll pass these are called some parameters and we'll pass the arguments and you will do all these things. Now it becomes easy. So first def withdraw it will come here, then def deposit, then balance, then the balance is then the function will be called balance withdraw. Withdraw equal balance of 5,000. Now this function gets called, so it goes here. Withdraw balance of 5,000. 10,000 balance is 10,000 comma 5,000. So new balance is equal to balance 10,000 minus 5,000. So a new balance is equal to 5,000 return new balance. It becomes returns new balance. Balance is equal to 5,000. Now again the second function is deposit. Deposit balance of 3,000. So now this function again calls this deposit 5,000 comma 3,000. So new balance enta 3,000. Amount enta amount is 3,000. Balance is 5,000. So now these two gets added up and it makes new balance is equal to 8,000 and it returns new balance. So what's changed? Global mess. Hidden changes. There are no hidden changes. It's not hard to debug. It's not unsafe. Like global mess, not testable, not scalable. Whereas coming to local, it's full of clarity, explicit, implicit output. It's very easy to trace. It's very safe. It is testable. It's production ready. Global variable, it's like just a office notice board. Anyone can erase and write. Whereas local variable is like your personal notebook. Only you can control it. So local variables makes functions predictable, testable, and safe. So one line to remember, functions should not securely change the world. They should return results. Functions should not secretly change the world. They should return the world, return results. So this completes the local variable. Now there are other types of variable, but global variable, as I say, global variables defined at a module level are accessible anywhere inside the program. So let's now why get into why. Mm, so we'll just take the copy of this. Mm, okay, we'll so now here we are going to discuss the global variables, why it actually came into picture. Problems before where imagine every function has its own separate memory and could not see common data. So now suppose 10 functions need the same value Python. What you will do, copy Python inside every functions. If value changes, update it to 10 places. High chances of making mistake. Repetition plus so this is the reason. Whichever the things you wanted to repeat, like every function should contain some the every function should have the value Python. Then each time you should repeat and each time you should copy paste. And if somewhere one wrong goes, entirely it goes wrong. Repetition plus inconsistency. This is why global variables came into picture. So global variables solve share data problems. Some data is common for entire program. So we what we do, we declare outside the function and we declare one plus and keep on using it. Define once, use anywhere, easy to maintain. So here is a real life analogy. So house notice board, global notice board in the hall. So like anyone can define once. It's used by everyone. It's very easy to maintain. Local verb. It's only the notes inside your room. Everyone in house can read the notice board, but your room note is only for you. So Python. So reading notice board. Real life software example. So app name is equal to so Instagram and version is equal to 1.1. Used in UI, used in logs. Image parsing these values to every function. Global variable avoids that. Another example. So score is equal to 0. Global score is. Since score belongs to entire game, not a function. Global variables come into picture to store data that is common for the whole program. It is used. It should be defined once. Should be accessible anywhere. Global variables are powerful but risky. Any function can change them. Hard to debug big programs. Bad in multi. That's why use global sparingly. Prefer function argument classes. Global variables exist to avoid duplication of common data. Yeah, this is the most important thing. Exist to avoid duplication of common data across multiple. But misuse leads to chaos. So this completes the global variable. Now we'll go to instance variable. So, okay. Instance belongs variable that belongs to individual objects of a class student. Okay, so we'll define the constructor in self comma name, self dot name. S1 is student, S2 is equal to student Priya, S1 dot name and S2 dot name. So now let's go to the chat GPT and let's go to instance variable. Let's scroll back to the beginning of the page. Yeah, let's answer the instance variable came into picture using real life plus programming reason, not theory. So I just want to check if the recording is still going on here. Yeah, it's going on, not an issue. Okay, now let's continue with the instance variable topic. The real problem first. Before instance variable, imagine a student system. You want to store Ravi's name, Priya's name. If we had only normal or global variables, what happened? It is overwritten. Only one value can exist at a time. So the problem was how can we store each student data separately? So class creates a blueprint, not a storage. So student is just a design. Class name is just a design. It does not store any real data. Real data lives inside the objects. Now we have two separate students in the memory. Why instance variables were invented? Each student must have their own name, their own marks, their own data. Data must be attached to the object, not shared. It should not be shared. That's when instant variables came in. Instance variable is equal to object personal data. So class student is class name and def init is a constructor. Self is a keyword which holds the address of that object, and name is a some variable, or here it's passed as an argument. Self.name is equal to name is an instant variable. Self is a current object, whereas self.name variable inside that object. Memory picture, s1 is equal to object, s1 is object. Okay, in that name is equal to Ravi, and s2 is called object, in that name is equal to Priya. S1 dot name is equal to Ravi. No overwritten, no conflict, clean design. If name was shared, Ravi, what if instant variable doesn't exist? Ravi changes name, Ravi changes name, name changes. One student affects another. Impossible to build real time. Every real world needs has every real world entity needs its own. Each form fills their name, roll number, marks. The form is a same class. Data is different. Instance variable. Variable come into picture to store object specific data so that each object maintain its own independent state without interfering with others. So now the quick comparison: class is blueprint, object is real world entity, instance variables object personal data. Okay. uh, Now I just want to pause the recording for a while, so we'll discuss on another topic called as self keyword. So self is a parameter which stores current object address in hexadecimal value. ID is a predefined function which is used to find the address of a current object. Suppose it's a class student, and we have created the function def read self, print ID of self. So S1 is one object, and we are creating an object using the student. How do we call this uh, class class? So we call the class using the student and parenthesis. So after this, we'll call the function. Once we call it, it will call s1. S1 is the it will hold some address, current object address. Then it s1 and self both are the same, so it will hold the same address. Then once it goes here, it will print ID of self. What is the ID? ID of self is this much. Print ID of s1. Both are the same. So inside the function you can print. Outside the function you can do the exercise. So this is all about self, and you can go to this PDF for later. So now let's jump back into the let's get back to the concept. So this is how the instance variables everything work. If you want, now we'll go to the class variables. So class variables shared by all instance of the class. So now let's go back to the class variables. Problem with before class variables. So imagine this without class variables. So definite self dot name is equal to name, self dot school is equal to ABC school new, S1 is equal to student, S2 is equal to Priya. Is copied into every object. One student is okay. Hundreds, thousand students, waste of memory. So and update problem. School names changes to XYZ school. You must update every object. Missing one, inconsistent. It becomes inconsistent, and it takes more time. So conceptually wrong. A school belongs to a class student type. not an individual string. So Python nearly very rare. Why class variables came? Some properties are common to all objects. That's why all students study in the same school, all employees work in the same company, all calls of a model have the same manufacturer. These properties do not change per object, represent shared. Hence, class variables means this property belongs to a student carrier, not on anyone's student. So, so hence class variables do not change per object, they represent shared identity. Memory and behavior advantage. S1 is equal to student Ravi. S2 is equal to parent. School exists only once in the memories. S1 dot lookups the class, lookups the class. S1 dot school lookups the class. And okay, S1 is equal to student Ravi. S2 dot school lookups the same value. So S1 dot school. S1 dot school object also address, then it goes to school. No duplication, easy updates, clean design. Each students carry their own printed this real element, real one without class variables carries their own timetable according to them everything. But with class variable, we can a school name is written on the school gate, and all students must refer to it. So you can think like a without class variable, each student carries their own printed their own um, their own printed timetable. But when it comes with the class variable, a school name, that the school has one particular timetable, and everyone has to, all students has to just refer it. Use class variables or data objects is common to all objects. Data represents identity or policy. Data should be changed globally. So these three are important. Interest rate, car. When not to use them, it differs per object. If changing, it should be different. So we can't use the class variables when each one has different things. If value differs per object, if changing, it should not affect us. This belongs to instance variables. So instance variables, who you are. Class variables, where you belong. So sorry, I don't know what is this, but just I have understood the class variables and the mm, and instance variables. That's fine. That's cool. Great. Now let's go back to the PDF again. Variable names. So these are the variable names, naming rules. So let's go back to the PDF again. Variable naming rules. So variable naming rules. Variables must contain a letter or underscore. Variables can contain letters and underscore only. Python is case sensitive. Reserved keywords may not cannot be used variable names. Best practices. So I don't know whether the okay. Okay. Best practice. Use snake case for variable names. Use descriptive variable names. Use uppercase for constants. Use underscore for private variables. Okay, variables rules come into picture to solve real world problems in programming systems, not to trouble beginners. Computers need clarity, not assumption. Programming language must be ambiguous, predictable, fast to parse. If we allow anything as a variable, then the computer gets confused. Imagine that the computer cannot decide the two values never. The minus subscription or part of a name. If logic is a variable, removes ambiguity. Why variable must start with a letter underscore? So no, letter numbers having meaning. Already they have meaning. Parse from left to right. Starting with letter tells Python this is a name, not a value. Is allowed to support private variables, internal usage, avoiding keyword conflicts. Why only letters, numbers, and underscores? Space separates tokens. Minus subtraction operator. All other things are language. These are symbols for operation, not names. Why Python is case sensitive? It has two different variables. Computers treat characters as ASCII or in. Case sensitive increases naming flexibility. Consistency in file system and OS avoids hidden overrides. Without case sensitivity, so the T is totally is all here also 10. Here also is 10. Overrides silently. If you have case sensitive, then it will have two different variables. Why keywords cannot be variables? Keywords are just like language grammar. If you can't rename verb in English, you can't use if as a variable in Python. If is equal to false. If language will break. So came later, human problem. Rules for machine. Best practice for snake case. Total amount is equal to readability, easy scanning, standard across Python. Descriptive names. Code is read 10x more than written. Total salary is equal. Upper constants. Do not change this. Prevents accidental bugs. Underscore for private variables. It's used for internal use, not part of public API, avoids misuse. Variables exist for the computer to understand code. Naming best practices exist for humans to understand code. Variables exist for the human, for the computer to understand what we are telling, what we have written code or to understand. Naming best practice exists for human to understand the code. Okay, I think let's okay. Then we come to variable assignment types. So let's go here. So here, why variables assignment types came into picture. Let's answer this the same way these concepts were born from problems, not syntax. Why variables? To reduce effort, avoid bugs, and match how humans think. Early programming had only one kind of assignment. So, but as the programs grew, new problems appear. Each new assignment type was introduced to solve a specific pain. Simple assignment. Why it exists? You need to refer. You need a name to refer a value in the memory. So without it, code becomes unreadable and useless. This is the foundation. No problem here. Multiple assignments, same value. So x is equal to y is equal. So here you are using the repetition. You are taking the more lines. Here high chance of mistake. Why it came? Drive. Don't repeat yourself. One value, many references. That's these all start with that same default value. Multiple assignments, different values. So here data is naturally grouped. Here it's cleaner, order-based thinking, very human. This matches real life unpacking. First goes to X, next second to Y, third to Z. So yeah, so number is equal to you form a in list 1 to 3. Then we are unpacking it. Numbers before A is equal to number sub 0, index error, ugly code, tight coupling to positions. Why it can treat collections as a whole unit. Let language handle indexing safely. Let it handle it. Why we need to bother? Split the box into these names. Parallel assignment often comes in pairs. Very common in math, coordinates, config returns. X gets this, Y gets that together. Swapping without temporary variable. So this is the point we need to have extra variable, easy to mess up, not initiative. So with using the what do you say this parallel assignment, we we are able to have same bug free reads like English. Python does pack, it does unpack. Too much repetition, solution, multiple replies. Indexing errors, unpacking. Messy swaps, parallel assignments. Hard to read code, human like language evolved to reduce thinking cost. Reduce, not to show off syntax. Humans think in groups, data comes in bundle, mistakes happens in repetitive code. So this is done. Now let's focus on Legby rule. Python follows local enclosing global built-in order while searching for address. So this is the program. Now let's go to this child while let b rule exists. Now let's go to the above. Okay. Variable scope like we came into picture. Before scope rules, programming faced three deadly issues: naming conflicts, unpredictable behavior, impossible debugging. Let's understand why leg became nicer, not just what it is. The fundamental question what computers must answer is see what when Python sees a variable like x, it must decide which x are you talking about. Suppose here is one global x, here is one local x. Should you point and print that point? Not it is full confusion without rule. So Python let's treat unpredictable lookup order. So that's why not make everything global? Yeah, why not everything global? Image this is a real world scenario. So balance is equal to 1000 and deposit balance is equal to this. Then so now it gets confused. Now balance is either balance is 1500 here, 1000 plus 500 total become. Now withdraw is 1000, either 1500 or 800 is the balance. Now it becomes problem. Multiple functions modifying the same variable. One function breaks another. Bugs appear random. Multi-threading becomes an idea. So global creates a chaos. Chaos. Functions should have their own specific space. That is local space. Why why enclosing scope was needed? Nested functions. Now let's consider closures. There are two nesting functions. Nesting functions, outer and inner. So x is not local to inner. X is not local to inner. So that means x is not inside the inner, so it is not local. So where should Python look? Enclosing scope was introduced to allow inner functions to remember outer data. So enclosing is to enable this enables closures decorator file. Without enclosing scope, modern Python breaks. So we can print this using the x is equal to it prints the functions. So why built-in scope exists? Yeah, where it's print defined, not local, not global, not enclosing. Python provides a built-in scope, so those are always available. Final solution. Search variable in the closest and safest place first. Local, inside current function, enclosing, outer function, nested, global, module level, built-in default methods. This guarantees predictability, safety, and zero ambiguity. Okay, global x is equal to enclosing x is equal to goes here print x. So inner functions does it. Now x closing print x. It's now outer function prints global. That's it. Inner finds x locally, stops searching. Outer finds on x. Global remains untouched. No collision, no confusion, no side effects. Local nickname at home. Enclosing family name. Global official name. Built-in government ID. Nickname at home. Enclosing family name. Global official name. Uh, when someone calls you, they check closest identity first. Actions. Okay. So here is all about Python looks for variables for nearest to farthest. So this is all you can go through everything and just go through it and yeah, this it. Okay. Okay. So I need to stop till here. Dynamic topic. The